All right, so pretty sure that this is working. It's been a while. We're going to talk about integers, rational numbers, and absolute values. So this is day one of this. There's will be a day two as well. Our learning targets are to graph rational numbers on a number line, to find the absolute value of a rational number, and to use the number line to compare rational numbers. So rational is one of these key words that you see 3 times here. So we've got to make sure that we know what a rational number is. So that's an important thing. Also, you'll notice that it's on here once, but absolute value. That's what we're going to spend a lot of time working on today. So looking at this, first of all, I'm just going to start you off with some vocabulary. The integers are the set of whole numbers. Now remember, whole numbers, they start off 0, 1, 2, 3, and so on. And they're opposites. So integers, then, are made up of all the numbers like -3, -2, -1, 0, 1, 2, 3, and so on and so forth. They'll keep going. So next, we're going to actually mention what the rational numbers are. The rational numbers is a number that can be written as A over B. By the way, that means it's a fraction. Oops, fraction, F-R-A-C-T-I-O-N. Where A and B are integers and B cannot equal 0. And B can't equal 0 because you can't have a 0 in the denominator of your fraction. I'll also mention that all the decimals that we'll encounter in the near future will be rational. Please listen to me carefully. The decimals you see this year, except for one of them, are all going to be rational numbers. Next year's decimals, though, will start to include another set of numbers. But right now, if you see a fraction or a decimal, it's rational. Absolute value, then, is the distance between a number and 0 on a number line. And our absolute value is written with this bar, A, and then another bar. So the absolute value of -4. If we look here, plot -4 on the number line, -4 is 4 units away from 0. So the absolute value of -4 is 4, because -4 is 4 units from 0. Likewise, and I'll switch up the colors here so that we can tell the difference between the two. Likewise, if I plot 4 on the number line, 4 is 4 units away from 0. So the absolute value of 4 is 4, because 4 is 4 units from 0. So we'll just practice finding the absolute value. We want the absolute value of 1 1/4. The notation for that is 1 1/4. Plotting the value, 1 1/4 would be between 1 and 1/2. So it's right here on the number line. And it's 1 1/4 units away from 0. So the absolute value of 1 1/4 is 1 1/4. So the absolute value of -3, the notation is bar -3, bar. The value, -3, is right here, and -3 is 3 units away from 0. So the absolute value of -3 equals 3. The last one is find the absolute value of 0. The notation is bar 0 bar. And if we plot 0 on the number line, 0 is 0 units away from 0. So therefore, the absolute value of 0 is 0. 0 is the only number like this. So here we go. So the absolute value of 7. What you should do right now is you should pause this video and try to see if you can answer these absolute values and try to determine if these numbers are integers or rationals. So go ahead and pause the video, try to come up with your answer. I'll wait. Welcome back. The absolute value of 7 is 7, and 7 is an integer. The absolute value of negative 5/3 is 5/3. 5/3 being a fraction is a rational. And then negative 2.6, the absolute value of negative 2.6 is 2.6, and since 2.6 is a decimal, it's a rational number. Hopefully you got those right. If you didn't, you should go back and rewatch the video from the start to go back and take a look at the definitions and the prior examples. Finishing this up, we're going to compare rational numbers. So we're going to compare absolute value of negative 2.5 and the fraction 3/2. So the first thing we'll do is we'll get them to look like they're the same form. So we'll get all the noise, so all the symbols out of the way. The absolute value of negative 2.5 is 2.5. We want to change 3/2 to a decimal. We're going to divide 3 by 2. So 2 goes into 3 once. 1 times 2 is 2. 3 minus 2 is 1. We need to add a decimal point and a 0 to the end of the number 3, which means we'll put a decimal point up there. Bring this 0 down, and that gives us 10. 2 goes into 10 5 times. 10 minus 10 is 0, so we're done with our division. That means that 3/2 is equal to 1.5. So when we go down to the bottom here, I'm just going to ignore the number line. The absolute value of negative 2.5 we know is 2.5. 3/2 is actually 1.5. Therefore, we know that 2.5 is bigger than 1.5, and we use the greater than sign. You should pause the video again and try these next 3. So again, don't feel like you're in a hurry, but take a moment. Take a look at the first one. The second one you'll probably need to change some things around for. Third one you're going to need to do a little work on too. But stop and change them. Make sure that you can do them, and then come back and check your answers. I'll wait. All right, welcome back. The absolute value of 9 is 9. The absolute value of negative 9 is 9. These two are equal. So we complete the statement by saying that they're equal. 1/2. The absolute value of 1/2 is 1/2. And 1/2, in case you don't know, 1/2 is a decimal. 0, drop the decimal point. 2 goes into 10 5 times. So what we have then is we have 1/2, absolute value of 1/2 is the same as 0.5. But notice we have this negative sign out here. So we're looking at negative 0.5. Now over here we have 1/4. And so we're going to divide 4 into 1. 4 does not go into 1, so we drop a 0. 4 goes into 10 twice. That leaves us with 2 times 4 is 8. 10 minus 8 is 2. Bring down another 0. Bring down the 0 again. And so that gives us 4 goes into 20 5 times. That gives us a 20. We subtract. That's a 0. So we get, and notice that there's a negative sign here. So it's negative 0.25. Now on a number line, negative 0.5 is to the left of negative 0.25. And so therefore, since it's to the left, it'd be less than. The last one, we have the number 7. That's simple enough. But over here we have the absolute value of negative 4.5, and then we want the opposite. So if I take the absolute value of negative 4.5, that's just 4.5. But then I have this negative sign, which tells me I want the opposite. So if we look, 7 is greater than negative 4.5. In fact, every positive number is bigger than every negative number. So therefore, our answer will be greater than. So hopefully you got equals, less than, and greater than. If you didn't, hopefully my explanation is clear. If it's not, you should contact me at your earliest convenience. There's a short assignment for you to try on your own.